Alright, so today we're going to be getting started on an 820-00426 board. This doesn't appear to turn on properly, and since I randomly picked it from the pile, I'm sure it'll be a difficult one. So, what we're going to do here is we're going to plug it in, turn on the power supply, and it does give us a green light, but no fan spin. So I'm going to open up a schematic for the most similar board to this one, and we're going to see if we can solve it. And the most similar board that I'm going to find to this one would be an 820-00163. And being how random this board was from the pile, I guarantee it's going to be a really difficult one. So, first thing we're going to do is check the list of power rails and see which rails show up and which rails don't. Where can we find our list of rails? It's going to be on page 84, because why wouldn't the most important part of it be on page 84? So the first rail here is PP bus G3 hot. That's going to be present on a fuse that's right over here. And I can see that fuse without using a microscope because it's a very small fuse. So I'm going to do this. I'm going to do this. And it looks like we get 1.5 volts. 1.5 volts is not appropriate. Now the chip that creates PP bus G3 hot is on this side of the board, and since this is the board that was picked at random, this is probably not going to be an easy repair. So let's take a look at the part of the board that creates PP bus G3 hot, and oh look! One bad capacitor. My. Imagine that. Imagine that. Random.
What the fuck?
Alright, so let's see how... Good night. So let's go ahead and fix this board, shall we? So I'm not going to trust that ISL 6259 very much. Nor am I going to trust the stuff around it. Alright, capacitor removed. Now we're going to check around that current sensing circuit and see if we're getting the impedance that we would expect. I would typically expect around 20 ohms in between here and here, and it looks like we get 12 million ohms. This resistor over here is measuring 10 ohms. This resistor here is measuring 10 ohms. But from here to here, 10.3, aha, 18.4 million. Now, let me show you why this is bad. This is supposed to go to here. This is then supposed to go to here. And from there, it's supposed to go to here. How's that going to happen when it's all corroded up and broken?
What's the temperature before when I remold this? Or just reuse the airflow?
I would lower the airflow to 90 or 80. We're going to scrape away. Now if we take a look at the schematic in the board view and we look at U7100, which is this chip, we'll see that our problem here is a problem with current sensing. We have pin 27 and 28. Pin 27 and 28. This is for current sensing. The way this works is the charge is going to be up here. The adapter voltage is going to come here from adapter. It's going to go through Q7180. and then it's going to go to this current sense resistor before it goes to these two transistors, which are going to switch your 18 volts into 12 volts by turning it on and off and on and off again. It's going to get evened out through the coil and with these capacitors going to ground over here to create a nice 12.6 volts on PP bus G3 hot. Now, all charger voltage is going to be going through this circuit. As a result of that, this resistor over here is going to have all the charger voltage going through it. Now, there's going to be a teeny tiny voltage drop across that resistor, and the voltage drop across that resistor is going to be directly proportional to the amount of current going through the circuit. More current going through the circuit, greater voltage drop across R7120. Now, what's going to measure the voltage drop across R7120 to make that determination? U7100. U7100 is going to measure that on pins 27 and 28. Now, instead of attaching U7100 directly to the top and the bottom of R7120 so that you could see what the voltage difference is, they have a 10 ohm resistor in between R7121 and R7122. So, a quick way to test that the circuit is working is to measure the resistance between pins 27 and 28. The resistance between pins 27 and 28 should be the sum of all the resistances in series. So we should have 10 ohms plus 0.02 plus 10 ohms. If we don't have that, it's not working properly. And the resistance that we were getting was in the millions, which is no good. See? Look at this. No good. 35.17 million ohms. Impossible. So let's see where the break in the line is. It's not here. That's 10 like it's supposed to be. It's not there. It's not this resistor. Is it this? No. Is it this? Yes. So from here to here is broken. So we can fix this easily with a micro pencil. You can get a micro pencil using the affiliate links below. Check out the T30-KN tip available on the HAKKO 2032 iron. Don't delay. Buy today. First thing I'm going to do, if there was water over there, I'm not going to trust the solder joints on this ISL. They're probably good, but I would like to touch them up. Next thing to do is touch up the point that's actually broken. And that's going to be the right side, and I imagine that's broken because of something that Alex did. Why would Alex break this? I'm not sure what he had against this little board. Alright, let's get in there. Solder, solder, and the break becomes obvious. Look at that. Ouch. See the break? Between here and here. Not touching. Well, we're going to make them touch. That sounds kind of dirty. Can't make things touch. Supposedly at NBC you can't hug. Ugh, that capacitor's gross too. Let's get rid of that. Did you read the article Gizmodo wrote about? I don't read articles that Gizmodo writes, honestly. If it came out of Gizmodo, it's usually probably shit. Alright, so there's a hole in the board over there, so I'm probably not going to resolder what that is. And I do have a faint memory from an older board repair that it's not necessarily very important. So I'm going to put that capacitor that's supposed to be there back, and after I put the capacitor there, I'm going to run a little wire. I like for that wire to be nice and flat if possible, and there we go. Nice and flat, reattached to the trace. And just because I'm a crazy person, I'm going to even reattach it to the chip itself. Because I wouldn't... All right. This board has fan spin. Look at that fan spin. So what was the problem with this model board? Well, it seemed like the issue with our board was that the current sensing circuit wasn't working. And the reason the current sensing circuit wasn't working is because there was corrosion over here, right where R7122 meets U7100. So we learned what a current sensing circuit is, we learned how the current sensing circuit works, and we learned that this current sensing circuit failure causes this chip to realize, oh my God, look at the difference. Up here we have 18 volts, and down here we have 0. That's way too big a difference. That must mean the charger is using too much voltage. Shut it down. And it decreases our PP bus G3 hot over here to 1.7 volts from its standard voltage of 12.6. So that's it for that. And as always, I hope you learned something.